This machine does the three tasks that I always use the radial arm saw for: cross-cutting, miters, and compound miters. But it can't take a dado blade and it can't be used for ripping. It's not the complete shop in itself that the radial arm saw can be. In the 1950s, the radial arm saw was sold as a one-tool shop. Many people learned their woodworking on it, including me. You can obviously cross-cut with it, but you can also rip and do a lot of other things. Sears sold a drill chuck that you can mount to the end of the motor shaft, and DeWalt even sold a saber saw attachment. Tuning the radial arm saw can be tricky because there are so many moving parts that you've got to adjust in just the right sequence. Raise the arm so that the blade is free of the table, and then lock the motor in the middle of the arm. Check the rise and fall of the arm with your finger on the column. The up and down movement should be smooth without jerks or roughness, which would indicate dirt or lack of lubrication. Pressure on the arm either up or down or sideways should not cause any movement at the column and base junction. The column rises up through a split base which functions as a clamp. The column's motions can be eased or tightened by turning these bolts. Move the arm out of square, then let it click back in and wiggle it to make sure it's seated well. Check for sloppiness or roughness in the yoke mechanism by trying to rotate the yoke and then sliding it. 4 rollers support the motor carriage and slide in tracks on each side of the arm. Dirt or sawdust in the track causes a rough movement of the carriage. Clean the bearings by applying pressure against them as they roll in the track. If you pull the carriage backwards, you won't pinch your fingers. Test the tension on the bearing by pressing your thumb against it as it rolls. If you can stop the bearing from rotating, it's too loose. An eccentric bolt adjusts the bearing on one side of the track. Lubricate the track with a very light coating of a fine machine oil to prevent rust. The column should be oiled with the same type of oil and then raised and lowered all the way to spread the oil. Now you'll need to remove the guard and the blade to do the rest of the tune-up. The first step is to make sure that the arm and the blade are parallel. Tilt the arbor toward the table. Make sure that the pin lock is engaged completely. Use a paper shim as a feeler gauge. Test the table on all 4 corners and in the middle. If you don't get identical readings all around, you'll have to fine-tune the table height. Each manufacturer has a different mechanism for this task, so consult your owner's manual. Squaring the blade to the table comes next. Make sure that the square is not touching a tooth, both top and bottom. On most saws, the lock screws are at the front of the yoke. Free them up and then tilt the blade to square. Recheck the blade after you've tightened these. It may have moved a bit. Start squaring the blade to the table by marking a tooth, any tooth. Set the square at the back of the table against the tooth and draw the carriage forward. The tooth should scrape evenly against the square. If not, loosen the table mounting bolts and tap the table into proper square with the blade. Repeat the test until you have it. There's another alignment problem called heeling, which occurs when the blade travels through the cut at a slight angle. The leading edge or toe and the trailing edge or heel are not perfectly in line. The heel rubs against the wood, making a double cut or a burn. When ripping, it can cause a dangerous kickback. Heeling occurs both vertically and horizontally, which is a point ignored in most owner's manuals. The adjustments are made at the back of the saw where the motor rotates in the yoke. Here is a real simple fixture for detecting heel. It's just a 3-inch by 12-inch piece of plywood with one corner cut off. I use the cut off corner first to measure the horizontal heel. Rotate the blade backwards until it touches the plywood point and makes a noise. Mark the tooth or teeth that made the sound. Then slide the carriage to test the opposite side. If the marked tooth makes the same sound on both sides, then there's no heel in the horizontal plane. Then clamp the long piece of the fixture to the fence and tap it so that it just touches the tooth with the most runout in the vertical position. Then mark that tooth. Just as we did before, slide the carriage back and listen again for that noisy tooth. If there is vertical heel, you'll hear either a louder sound or none at all, depending on the direction of the heel. To adjust out horizontal or vertical heel, slightly reposition the motor bushing at the back of the yoke. Then reset the jig and test again. That's what you want to hear. The same sound on both sides means zero heel. Here's the one-cut test for the saw setup, using a piece of plywood with parallel edges. Reverse one face to check for blade square to the table. On edge, with one piece still reversed, you're testing for the blade being square to the fence. There are two approaches to using the radial arm saw. If it's the only tool you have, or if you're hauling it to a job site, you can use it for all your cross-cutting, ripping, or mitering. The other approach is to get everything square and leave it there and use the saw exclusively for cross-cutting. Then when you need to make a miter, use jigs or fixtures to hold the workpiece at the correct angle. This simple jig acts as a miter fence. You can use it to cut both sides of a molding. A flange at the back drops into the regular fence slot, and the whole jig is clamped in place. A variation of this jig has a double adjustable fence. It's very handy for cutting compound miters like those in cold molding. The double fence allows the molding to sit up in the same position it will take between your wall and your ceiling. So it's cut perfectly.